Okay, now we're up to exercise 8.6, constant and variable rates. So it's two different things here that we're going to learn about. So constant means when the variable changes, so when one goes up or down by the same amount every hour or every minute or every person or every number of ice creams, it'll always be a straight line. So that might be how fast you run. So every hour you run 5 kilometres. So 1 hour would be 5 kilometres, 2 hours is another 5 kilometres. If that's the case, then it's going to be a straight line. If someone sells 10 ice creams every single hour, then every hour it'll go up by 10 and this will become a straight line. So I'll show you that here. So for instance, if you get a graph looking like this, so you've got number of people up the Y and you've got number of hours along the x-axis. First of all, is this a straight line? So if we were to put a ruler on that, the answer would be yes. Okay, and how can we work out the constant rate? So it is constant because it's a straight line. And the second thing is, how can we work out what this rate would be? And the way we do that is just by working out the gradient of the line. Okay, and I think when you've got a graph like this, the easiest way of working out the gradient is rise over run. So if we look at this graph, we go, how far did we go up? We go 10 people every 1 hour. We go up 10 and we go across 1. So the rate is 10 people per hour. And as I was saying before, this is a constant rate because in the next hour, there's another 10 people. The difference between 20 and 10 is 10. And so on for the next one. So your answer is it a straight line? Yes, therefore it is constant because it's a straight line. And secondly, it might ask you what the constant is, so how many people is per hour. To do that, we'll use the gradient, okay? So let's have a look at a couple of questions like that one. So let's have a look at this one first off. So we have a graph here, and up here is D. You can see that. Let me see. There we go. Distance in kilometres, and then across the bottom we've got time in hours. This graph shows the distance travelled by a car. There are 3 distinct times of travel. Describe what is happening at these times, including kilometres per hour. So what that means is you actually split these into different time periods because they're not one straight line. So you might get 5 different sections and you just deal with them separately. So if we have a look at section 1 here, all right, we're going to say, if we work out what's happening at section 1, we're going to do rise over run for just that section. Okay, and we see we can go up first. Rise is how far up. So we go 20 kilometres in distance and we divide that by how much time that is in hours. So we go across. So we've gone up 20 and we go across 1. So that means we have gone 20 kilometres per hour. All right, so that's how fast you're going. So let's have a look at the next part of the graph. So in this part of the graph, think about what's happening. So time is going from 1 to 1.5 hours, but the distance is 20, and after half an hour, it's still 20. So what does that mean in terms of how far you've travelled? After 1 hour, you're at 20k away from home, say. After 1.5 hours, you're still 20k from home. So a straight line that is vertical means time has gone past, but you've not gone anywhere. So number 2 section is like this. So we might write vertical line. And a vertical line always means that you haven't travelled anywhere. So you have stopped. Okay, and that's because there's no rise. So when you do rise, you don't go anywhere. So that would be 0 over 0.5, the run is 0.5, and that would give you 0. So you've gone 0 kilometres per hour. So you have stopped or not travelled anywhere. And just, you don't ever have to show the working out, but we're going to show it here. It's just what I said then, just to prove it. So if we're going to look at that section of the graph again, the rise over run, rise is 0 because you don't go anywhere. You're still at 20. Over run is 0.5, but it doesn't really matter. It's 0 kilometres per hour. So this graph here says the person travelled 20 kilometres per hour in the first hour, and then they did nothing for half an hour. Now, what happens in the third part of the diagram? Let's have a look. So if we're going to do rise over run, we've gone from 20 here to 100. So rise over run, how far have you risen? You've gone 100 minus 20, because you've gone from 20 to 100. So you've gone this distance, whatever this is, which is 100 minus 20, which is 80. And how far have you gone across time-wise? You're at 1.5 hours and you get to 2.5 hours. So you've gone for 1 hour. All right, so that would be 80 over 1. So that is 80 kilometres per hour. So if you were telling a story, which sometimes you are, you have to say in the first hour, we were going quite slow. We went 20 kilometres per hour. Then we stopped for half an hour, and then we travelled fast at 80 kilometres per hour. And the other way you need to be able to read this is see how steep this is. This one is much steeper. So the gradient is higher, so you're travelling faster. So we're going to write along here, faster, because it is steeper. So this one is not as steep. Think about the hill. You come up to the hill, you climb the hill, you're going about this distance, that's 20 kilometres an hour. Then in this part, you climb a much steeper hill. So it means that you're going faster, which is what we've proven because we've done 80 kilometres per hour this time. Okay, so what about if you had to draw your own graph? So here we've got draw a graph of a jogger who jogs at a speed of 5 kilometres per hour for 1 hour, then doubles the speed for 1 more hour. So across the bottom, we only want to get 2 hours worth. So we're going to go 1 hour here, 2 hours. So we're going to put time in hours. And up the side, let's go 5, 10, 15. Okay, so in the first hour, draw a graph of a jogger who jogs at a speed of 5 kilometres per hour. So after 1 hour, 5 kilometres per hour means after 1 hour, you've gone 5k. So that's like the point 1, 5. After 1 hour, you've jogged 5 kilometres. Then it says in the next hour, so you're talking about this bit here, you go twice as fast. So twice as fast, if you were going 5 kilometres per hour, it means you're now going at 10 kilometres per hour. So we're going to go an hour, so we want to go up here. So your dot's going to be to the 2 somewhere. But you're at 5 kilometres per hour. This time, you're going to go faster. You're going to go 10 kilometres per hour. So from here, your rise has to be 10 and your run has to be 1. So we know we have to go across. From here, we've got to go 10. So if you only go to there, you've just gone up 5. So from 5, you've got to go 10k. So 5 plus 10 is 15. So your dot's going to be up here. So on this, you've got the start there, and then you'll see, actually mine's not very accurate, that the last 1 hour is steeper, okay? So this is 5 kilometres per hour, and this one will be 10 kilometres per hour. And this is steeper, therefore its gradient is greater. Okay, when you get to those type of questions, ask your teacher or come back to this example. over the page, I just have, and this is in your textbook and on your lesson plan, so it's very important that you know what this is talking about, is this little graph here. So in reality, so this is variable rates. So we've done constant. We also need to do variable. Variable means in real life, you don't go exactly all that way. You might on a freeway stick to the same, but then you'll find that you stop at traffic lights and all that sort of stuff. So it is actually in real life when we go in a car, it tends to not be at constant speed. It's at a variable speed. Okay, and the same happens though for what we did before. So low speed is a small gradient, high speed is a high gradient. So I'm not sure if you can see this. So this is in your text and in your lesson plan. It starts off here, which is slow. I've written slow. Greater gradient, higher speed. So it means it goes up a little bit, okay? And then when it goes, like it's going to go to a vertical line, it's slowing down. So this is slow. This gets a bit steeper, so it's faster, slowing down again, okay? And then when it finally gets completely vertical, like we said before, horizontal. Oops, I think I said, horizontal is correct. I'm sorry, I've made a mistake over the page. I think I said vertical line, and I don't mean that at all, do I? I mean horizontal line. So this means, I've written here, car is stationary. Car is stationary. So time has elapsed, but no distance, which is what I was talking about over the page. Oh, I really think that I wrote vertical. So please, I'm sure you're all screaming at your computer saying, no. Okay, so here we've got slow, graded gradient, higher speed, slowing down, and then when you get to horizontal line over here, you have stopped. The car is not moving. So that's a really good one to know. When the video is finished, I suggest you copy this down from your textbook or from the lesson plan. It's in the lesson plan as well. All right, let's have a look here. So the type of questions you're going to be asked. It's okay. All right, so what area is the steepest gradient, therefore the fastest part? A, B, or C? Hopefully you're looking at this and saying the steepest is the fastest. Well, the question says it, so the answer is A. Slowest part, still got to be moving, but it's not as steep. So that's going to be C. And not moving at all is our horizontal part, which is B. All right, we like those type of questions. They don't change very much. All right, what about the last type that you might get? Find the rate in kilometres per minute of the following. So the minutes are along the bottom, 5, 10, 30. The kilometres are up the y-axis, 1, 2, 6. Now, this we want to do without using a graph. So try and follow with me without drawing the graph. Okay, we want to know the kilometres per minute between the times 20 and 30. Now, we have the times 5, 10. We don't have 20. Okay, so we're going to think about this. From 5 to 10, we went 1 kilometre and it took us 5 minutes. So the next one in here to go 1 kilometre is going to take us another 5 minutes. So then if we go to 20, that's 5 minutes. So that part must be 4 kilometres. So I've just filled that middle bit out, which you could probably do in your head when you're doing these, or you could fill it in just quickly in your book. Now that we've got that, we have the 20 written here. So we want kilometres per minute between 20 minutes and 30. So what we want to get, as usual, of course, is the gradient, which is rise over run. And just make sure you do this correctly. Where's rise? The rise is always the y values, and the x is always the run. So this is rise. So rise is on the top. So you want the change in y values between 20 and 30 minutes. So here's our 20 and our 30. and the change in y values. So the rise on the top has got to be y values, rise. The change between 20